Here you can see a 3 by 3 matrix A. So we are going to find the inverse of this matrix. Here is a formula to calculate the inverse of a matrix. Inverse of matrix, any matrix is given by 1 upon its determinant times adjoint of matrix A. So if the determinant of this matrix is 0, then the inverse of this matrix is not possible. So only the matrix which have determinant non-zero have inverse. So to calculate the inverse of matrix A, first we need to determine the determinant of this matrix and then adjoint of this matrix. So let's get started. First, we are going to calculate the determinant of this matrix A. So the determinant of matrix A is given by 1 times 3031 minus it's 0, so it will be 0. 0 multiplied by anything is 0, so we can write only 0, plus next is 5 times 2, 3, 1 and 3. If you don't know how to calculate the determinant, you can watch my previous video on determinant of a matrix. So it's gonna be equal to 3 minus 0 plus 5 times 6 minus 3. It's just a simple process of calculating the determinant. It will be equal to 18. Now we have got the determinant of matrix A. Now next step is finding the adjoint of matrix A. You can see here we need to find the adjoint of matrix A. So now what is meant by the adjoint of a matrix? How do we find the adjoint of matrix? Adjoint of a matrix is the transpose of its cofactor matrix. So first we need to find the cofactor of all the elements of this matrix A, and the transpose of the matrix found by the cofactors as its elements gives us the adjoint of matrix. So first, if you don't know how to calculate the cofactors of these elements, you can watch my previous videos on minors and cofactors, and you can easily understand what cofactors are. So now let's calculate the cofactor of each elements. Now cofactor of A11 is denoted by capital A11, and it is given by A11 equals to, it is positive 3 0 and 3 1, determinant of 3 0 and 3 1. After cancelling this first row and first column, we get the cofactor of this first element. So now this is equal to 3. Now A12, cofactor of second element is denoted by capital A12 and is given by negative of 2 0 1 and 1. So it is equal to minus 2. Now A13 is equal to, it is also positive, it will be equal to 2 3 and 1 and 3. So it is equal to 3 times 2 is 6 minus 3 is equal to 3. So it is equal to 3. Now let's calculate A21, the cofactor of this element of second row and first column. So it is denoted by capital A11, A21. So capital A21 equals to, it is also negative, it is given by, after cancelling the corresponding rows and column, the remaining elements will be 0 5 and 3 and 1. So it is equal to minus, no minus, because 2 minus and minus are cancelled, so it will be equal to 15, positive 15. Now we are going to find A22. A22 is equal to, it is positive. So positive of 1, 5, 1 and 1. After cancelling the corresponding rows and columns, remaining elements are 1, 5, 1 and 1. So it will be equal to determinant of 1, 5, 1, 1. So it is equal to 1 minus 5 is minus 4. Now A23. A23 is equal to negative of 1, 0, 1 and 3, and it is equal to minus 3. Now A31. A31 is positive 0, 5 and 3, 0. So it is equal to minus 15. Now A32. A32 is negative of 1, 5, 2, 0. I hope you are understanding this, because it is a simple thing. You just need to know how to calculate the determinant of a 2 by 2 matrix and the concept of cofactors. If you don't know the concept of cofactors, you can watch my previous video. So it is gonna be equal to positive of 10. And last, we are going to find out A33, cofactor of the last element. It is positive of 1, 0, 2 and 3. So it is going to be equal to positive of 3. We have got the cofactor of all the elements of this matrix A. So now we are going to write these all elements in a matrix form, and we are going to form a cofactor matrix. So what is a cofactor matrix? So this is our cofactor matrix. We just need to substitute all the values that we just obtained, all the values of cofactors that we just calculated in this matrix. Now adjoint matrix is obtained by transpose of this matrix. So adjoint of matrix A is given by its transpose. Let's substitute the values of cofactors in here. So ADJ is equal to 3 minus 2, 3, 15 minus 4, minus 3 and minus 15, 10 and 3. Transpose of this matrix. This is our cofactor matrix. So transpose of this matrix will be equal to adjoint of A, and this will be equal to, how do you find the transpose of this matrix? You just swap the rows and columns, interchanging the rows and columns. So it will be equal to 3, 15 minus 5 minus 15 minus 2 minus 4, 10 and 3 minus 3 and 3, after interchanging the rows and columns. So adjoint A is equal to this matrix. Now we have the formula A inverse equals to 1 by A determinant times adjoint of A. Now we have obtained the determinant of matrix A and also adjoint of matrix A. So now we can find the inverse of matrix A also. So this will be equal to 1 by determinant of matrix A was equal to 18. So 1 by 18 times adjoint of A. Adjoint of A is, we just obtained the adjoint, that was equal to 3, 15, minus 15, minus 2, minus 4, 10, and 3, minus 3, and 3. So if we divide all these elements with this 18, after dividing all these elements with this 18 here, we will get 1 by 6, 5 by 6, minus 5 by 6, minus 1 by 9, minus 2 by 9, 5 by 9, 1 by 6, minus 1 by 6, and 1 by 6. So this is the inverse of matrix A, and in this way we can easily find out the inverse of any matrix. So thank you very much. If you like this video, please subscribe the channel and comment down below if you don't understand anything.